We're live now.
Okay.
Right. So do you guys just want to go and do part 2 of lesson 6?
Yeah.
Okay.
I'm just waiting for mine to come up.
Okay. Just let me know when you're ready, I guess, and we can talk about it.
Part 2 is only number 7, right?
I think there's 7 and 8. Yeah, there's 2 questions there.
Okay, I didn't see that.
But they're
Alright.
not too bad.
So number 7 says, randomly select 5 of the 30 salaries and compute the mean. And what is the mean of your sample?
So I waited to do this part because I thought we were supposed to do it together. So I can do
Okay.
it, or my part really quick. Sorry.
Oh, no, I haven't done it either because I thought we're supposed to do it together.
All right. Okay. So I guess
If we randomly select it, which ones should we select?
I don't know. Let's do 19, 27, 3, 12, and 21. Unless anyone has any objections. Those were just the first ones.
Which ones did you do?
19, 27, 3, 12, and 21.
Nineteen, 27, 3, and which else?
12 and 21.
Okay. So the mean was of that was 49660.
That's what I got to. Is that what you got, Alex?
I actually had opened the wrong thing, so I finally am catching up to you.
Oh, okay. We'll wait.
I went for homework instead of individual preparation, and it didn't look familiar to me, so sorry.
No, you're
fine. All right, so the numbers were 19, 26.
19, 27, 3, 12, and 21.
21. If you guys want to just keep going, I'll catch up.
Okay. So B says this graph illustrates the distribution of sample means. There are 142,506 possible combinations Of the 30 salaries drawn 5 at a time, this graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean for part A. So ours would be just below 50,000, I guess. Does your sample mean appear to be unusual? Explain why you think it is or is not unusual. It's more on the high end.
I think, I don't know, I think it's usual because, like what the text said, like, we only get to see our result. Like,
Okay.
this is only one of them, you know?
Yeah.
Like, if we did all of them, then
Okay.
we would be able to see it.
All right. I'm okay with that. Compare your mean from question 7A to the means obtained by at least 300 other individuals. What do you notice? In practice, you only get to see the means from the samples you draw. You don't get to observe any other mean that could have occurred. Oh, so I guess we
were supposed to do it individually.
Supposed to do, yeah, separate ones.
Oh, I didn't really know that, so.
Oh, that's fine. Now look at the blocks again. Just see here, I'll just really quickly do another one.
I'll do a different one as well.
Okay.
I'll just change one of the numbers.
Okay.
Well, I just did my different one, and mine's on the lower end, towards 40,000.
Okay. Well, mine's on the lower end too. 42,000, a little over 42,000. That's interesting.
Mine actually went on the higher end.
Oh, really? Where was yours?
Just under 51,000.
Okay. So I guess no one really got anything in that, or that median spot, right? We either were lower or maybe a little bit higher.
Yeah.
Okay.
Well, I think they're all within the bell curve. I would.
Yeah. They're all within the curve. Should we go to number 8?
Yeah.
The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample, or n equals 10 students taking GMAT. A, what is the shape of the distribution of the sample means for all such samples?
So it would be normally distributed.
So it should be the bell curve.
Right? Yeah.
Yeah, I think so.
Or would it be straight line?
And how do you know that the distribution of the sample mean has this shape?
Because it says it's normally distributed, and the normal all follow that uniform.
Yeah. There's that rule, right? One of the rules said that, like, if the parent population is one way, oh, that might be Trevor. Oh, Trevor's coming up. Let me just send him a chat really quick. Sorry, just a second. Okay. So C, what is the mean of the sampling distribution of sample mean scores for all such samples? 529, right?
Yeah.
Yes. No.
Just a second, sorry. Okay. And D, what is the standard deviation of the distribution of sample mean scores for all such samples?
Doesn't that be 113? Not according to
I think we have to use the formula. Like, it's a really simple formula.
Yeah. Okay.
I have to look it up. I forgot how it is.
Isn't it really similar to like the Z-score?
Mm-hmm.
Only instead the standard deviation part is a little different.
Yeah, square root something.
Yeah, it's like the standard deviation divided by the square root.
By square root of
sample.
10. Square root of 10.
Yeah.
113 over square root of 10.
Okay. Hi, Trevor.
Hey guys, I'm so sorry.
Oh, don't worry about it.
I was helping my brother move like all day, and I got back home and I fell asleep on the couch.
Oh, I'm sorry. It's a lot of work. I hate moving.
Yeah, that's why I'm late.
You're good.
I'm actually really grateful. My friend just called me because he was like, "Yo, are you doing that school thing right now? Or are you?" And so that's when I freaked out. So, oh my God.
We are on the lesson 6 preparation assignment, and we are just finishing question 8. So.
Okay.
Yeah. And we got it down. 113 divided by square root of 10 is 35.73.
Okay.
74. I think we want to go out to 3 decimals.
Oh, yeah.
According to the answer key. But yes, that is the correct number.
Mm-hmm. Do we want to go to lesson 7?
What lesson? What lesson did you say you're on?
Lesson 6.
Okay.
Preparation assignment. And did you have any questions about it, Trevor? Did you want to go over anything before we move forward?
Not really.
Okay. Cool. Well, I didn't think that one was too bad.
Mm-hmm.
So do you guys want to work through the quiz together and then move on to lesson 7? Or do you want to?
I would say let's do quiz, then lesson 7.
Okay.
So we're doing lesson 6 quiz right now?
Yeah.
Open it up.
I'm ready whenever you guys are.
Yeah, I mean,
Almost there.
Okay.
And ready.
Yeah, ready.
Okay. Question 3 says, when you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? And it would be skewed right. Yeah. Because it's supposed to be the same as the parent population, right? Unless the sample size is like greater than 30. And then that's large enough that it is more normal, right?
Yeah.
Okay. Question 4, when you're taking a sample size of n equals 100, what's the shape of the distribution when the parent population is right skewed? Normal. That's what I think.
and then number 5 is just skewed. Oh wait, normally skewed.
Yeah.
When you're taking sample size of n equals 100, what is the shape of the distribution mean? Depends unless it's normally distributed. Normal?
Yeah.
Normal.
And when would the distribution of mean be normally distributed? Population normal, sample size, I'll say yes. Normal distributed and sample size large, sure. And right skewed, sample size small. I pick those 3.
So everything but data are drawn from a population that is right skewed and the sample size is large.
Yeah.
Wait,
Isn't it? I don't know.
I agree with the second one.
Yeah, same here.
Data are drawn from a population that's normally distributed and the sample size is small.
I would say, I don't know. I think the third one should not be check marked.
Data are drawn from a population that's right
Is
skewed.
your third one the one that says data are drawn from a population that is right skewed and is small?
Yeah. Well, I'm not sure. I don't know. I'm not even
In
sure.
the general rule, we assume it's normally distributed unless we have a large sample. Or did I oversimplify it?
I thought if we had a large sample, it was closer to normal. Or normally distributed.
No, wait, question 4 is a large size. Oh, all right, well, if question 3 is correct, then Sheila is right, and the third one down is not part of it.
Yeah.
And that's the one that's data are drawn
Which
from.
means
Right. Small sample.
So
Right skewed.
so we're saying that the top 2 are right, and now we're saying instead of the third one, the fourth one is also right. Is that what you guys are saying?
Yeah.
That would match what we just previously put for the answers.
Okay.
Because all that were normal, we said were normal. All that were right skewed with a small population, we'd say were right skewed. So if this one is right skewed and the population is small, then it would not be normally distributed. But all the other ones would be, right?
Yeah, I agree with that.
Okay, then let's try that one then.
So which of the following gives the best explanation of the central limit theorem?
Sample size is large, shape will be normal. Fourth one down, on mine at least.
I'm looking at the textbook. I think the third one was mentioned in the textbook.
The one about the sample size or the sample mean will be close to the population mean.
Mm-hmm. But I'm looking at it right now, so we'll see if.
What's the other one called? There's a central limit theorem and the I can't remember.
Which one do you guys think it is?
I'm standing by my first choice.
Yeah, I'm kind of leaning that way.
Okay. So we could move on.
Yeah.
Let X be a random variable with population mean 10 and population standard deviation 6. Suppose a sample size or a sample of size n equals 36 is drawn from this population. It's the mean of the distribution of sample means.
N?
Wouldn't it be 10? Is that what you said, Alex?
Yeah.
Oh, I'm sorry. I agree. I think it's 10.
Yeah, it has to be
I was
10.
just looking up the more like the exact definition of central limit theorem. I still think Alex is on there. All right, and then 10. You said for 9 it's 10.
Yeah.
Okay.
Yeah.
And 10 standard deviation. Well, what is standard deviation? Just 6.
6 divided by
For the distribution of sample mean though.
square root of 36.
Oh.
If I did my math correctly, number 10 is 1.
Because the square root of 36 is 6.
Then the standard deviation is 6.
Yeah.
I'm sorry. I missed that. I was doing some. What did you get for the standard deviation of the distribution of sample means? So you did 10 6 divided by
Square
the
root
square
of
root of 36. Okay, so 1.
When did you get back? Oh, I thought you were.
Regardless of the distribution of the population, if the sample size is large, what would the shape distribution of the distribution of the sample mean? It would be normal, right?
Yeah. Well, question 12 says, what theorem would justify your response to the last question? It's the law of large numbers, right?
I think you're right.
Mm-hmm.
Yeah. So I was looking through the textbook. to go B. And yeah, I think Alex is right. So in the textbook, it says that the central limit theorem states that if the sample size is large, that S will be approximately normal. And the law of large numbers states that the sample mean will be close to, the sample mean S will be close to U. So
Okay.
it states that in there. So someone can press submit.
Oh,
No.
okay. I'll do it.
I feel like this made sense. Most of them. Are you submitting right now? Is that what you're saying?
I submitted it.
Okay.
Ah, the last one is central limit theorem, not law of large numbers.
Oh goodness.
Okay.
And what's
Right,
number
the
7?
distribution.
Do we get all the points for number 7?
Yeah, we got everything else right.
Did you roll up the windows in my truck?
No,
What?
did not.
Can you run out there?
Oh, yes, it makes sense. It is the central limit theorem.
Waiting.
Because it doesn't ask about the mean, it just asks about the mean.
Wow. Arizona would decide to just pour a ton of rain when I leave the window down in the car. Stupid.
Terrible luck. Sorry. Okay.
Yeah, I got it. Oh,
So lesson 7. Let me pull my note. I've got mine whenever you guys are ready.
Okay, so we're doing part 2 on the preparation assignment.
Yeah.
Okay. I bet I'll pull it up as well.
Are we ready?
Yeah.
yeah, I'm ready.
Okay. Are you ready, Alex?
Yeah.
Okay. Suppose pair computing sold an average of 45 p-phones per minute in 2011 with a standard deviation of 10, and they looked at their p-phone sales and sales data and determined that they are normally distributed. Sample of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution? I said normal. Because the original was normal.
Yeah, I'd say that too. Just because
Okay.
I don't know what else would be.
Okay.
Makes sense.
Okay.
So 5 sample size of 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X?
I said normal again because that sample size is large.
I'll agree.
Okay. Six says a sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is less than 40? You guys know how to work that?
Would this be something we'd use the applet for?
Yeah. So we take 40 and we plug it into the z, that formula, the z score formula, a kind of modified one.
The value minus mean over standard deviation.
Yeah. So 40 minus 45. Over 10 divided by the square root of 4, right?
So 40 minus 45. Yeah, and then the standard deviation originally it was 10 divided by. Yeah, square root of 4. Okay. I have so many tabs open. I need to clean
I know.
all this stuff. I just don't feel like doing it right now, but it's making it really hard because I'm like,
Yeah.
I don't even know why I have so many tabs open. There's like 15.
So I got a z-score of -1. And then you plug that into the applet.
0.5.
Oh, you did?
Yeah.
Well, because
45.
10 divided by square root of 4 would be 10 divided by 2. And then -5 divided by 5. There should be, I mean, I got -1.
So you divide by the square root of 10?
Yeah.
Square root of 4.
Or square root of 4, yeah.
Okay.
It's the kind of weird formula.
I'm doing the wrong math.
And it's everything that's less than that. So for the probability, did you get 0.159?
Yeah.
Okay. Beautiful. Makes sense.
Okay.
0.159. It's the probability.
Yeah, I'm good with that.
Okay.
So sample size of 4.
Mm,
Ah, it's one of those ones.
So I think this is the same kind of problem, and then
Just plug
you
into
just need to know, yeah, both.
We just have to do the middle. So
But what
since it's
I'm-
the same distance from 45, wouldn't we only need to calculate one z value?
Yeah, and
they're
then
both
just
10
double
away.
it. Yeah, that's what I was
Okay,
gonna
and then-
say.
And then we just get the middle. Okay.
Oh, I got -2. for my z-score for the one side.
Same. Well, the other side should just be 2,
So it
right?
would be, yeah, so it would be 2.
So it would be the probability of having it between those numbers would be 0.954 or 955.
Oops.
955.
Yeah. Is that clear to everyone?
Yeah.
Okay.
Yeah, so it should be 0.9545. That's what you should get.
No, I fell off the train.
You did. Where are you?
I'm still on 11. Or was it 12? I'm still playing.
These tabs.
Oh, I was on 8
Wait a minute.
or 7. Sorry.
Yes. No, like I said, I fell off the train.
Oh.
I'm still on number 6.
Oh, on 6. Okay.
So what formula am I doing? I got my z-score. I've got my standard deviation of all possible sample means.
So it's the it's the value minus the mean divided by the standard deviation divided by the square root of the sample size.
So
let
x
me
minus x bar, then that's over the standard deviation, but the standard deviation I'm dividing is the omega over the square root of x.
just a second.
Okay, if you, do you have the textbook open up? I can tell you where the formula is.
I'll share my screen.
That's
This
the
is
exact,
gonna be really ugly. Okay, but can you see that, Alex?
okay. Yeah.
So this is the this is the z-score formula that we're using. I don't know. Did I get the symbol right? Is that the right symbol? I think so.
The tail's facing the wrong direction, but
Oh, okay. Well, you get. I had a 50-50 chance. So, yeah. All right. So that's the formula. And then once you get that, whatever that is, you plug it into the applet at the bottom with the z-score, and then you just need to make sure that you are shading the right part of the curve, and then it'll give you the probability at the top.
Okay.
Is that better? I hope.
Yeah, now it's coming together. And I found where I put that in my notes, so it's tucked in a little corner where it's
Okay.
not noticed.
Got it.
But now it's coming together. Thank you.
So are we on number 7 now?
Are you ready for? Excuse me. Are you ready for 7, Alex?
Yeah.
Okay. So it's the same kind of thing, but they're just asking for like an in-between range of the two, like the low and the high number, and they're both the same distance away from the mean. So really you only have to do like half of it and then you just double it. You don't double it. That's how I explain it in my head. But you only have to work half the problem. You don't have to figure out the z-score for both of those.
Yeah, it's the same.
Yeah, that's what I mean. So we got I got 0.9545.
Yeah.
For my probability.
Yeah, 4 divided by 2 is 2. So the z-score will be the same, negative 2 and 2, which means the probability will be the same.
Right. So is that okay for everybody then?
Yeah, that makes sense.
Cool.
And then 9, it's just kind of the same thing. Just go up 1 higher. What is the probability that the observed x is greater than 50? So So 5 divided by 2, basically. So it'd be a z-score of 2.5. And then it's only the right side that we're doing, right?
Yeah.
So 2.5. And just the right. So I got 0.0062.
I got that too.
Yeah.
And that is what they have on the answer sheet. So that
Yeah.
makes sense. All right. 10. Okay. So paired computing sold an average of 40 p phones per minute in 2010 with a standard deviation of 12. They're looking at their p phone sales data and determined the distribution is right skewed. Samples of size n equals 4 are taken from the right skewed 2010 sales data. What is the shape? So that would also be right skewed.
Yeah.
And then the next one, because it's a large size, that would be normal.
Right.
Is there a theorem that justifies your answer? Yep, central limit theorem.
Right.
Okay, makes sense. So, okay, so these are the ones we actually got to calculate stuff. So 13, sample size n equals 4 is taken from the right skewed data. You want to know the probability that the observed x is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why?
So I had to look that up, and the answer is no, because it's right skewed and it's not a normal distribution.
And that formula is only for a normal distribution.
Yeah.
Because the sample size is only 4, it would stay right skewed. But in 14, because it's a high sample size, then we could.
Yeah.
Okay.
Then we can work it.
What is the probability that the x is greater than 36.5? Awkward number. Okay. So 36.5.
I'm so glad you came home today. Did you have any problem getting home? Did you go through a storm? I've never driven through anything that bad. I couldn't even see the highway. I couldn't see where I was driving. Walls of water. Did you ever smell like that?
No.
You go in Scottsdale, all of a sudden it's saying, don't use any of the middle lanes, trees are in the road. In the middle of the freeway, the 5-lane freeway, and came up about a mile later, there was a car about the size of mine on top of a tree. Had gone up and hit and stuck in a tree. And then there's branches probably from like you to me this big around in the highway. And it looked like an ocean. I mean, it was like there was waves in the water, and then a whole wall of water would just hit you. You couldn't see anything, it just blinded you for a minute. And I just concentrated staring on the thing. My phone died. I was afraid Dad would be really worried if I tried to pull over. And I kept thinking that if I could just get past this, that I'm in the middle of it. If I could just get past, like, on the outside of this room. Oh wait, I am picking up the track. I was holding on to this thing so tight, like this, that I was just cramping up. My arms are cramping up. We filled up the trailer huge completely, and then they had another trailer the size of mine, only been enclosed and like 6 feet high. Filled that completely, and then we're trying to go back for another load. And I told Aaron once they got one of those, like, I gotta go. I don't know if I have lights in the back of the trailer. He says, go ahead and get the last trailer, and I don't know if it hit them before they could even do that or not.
Wow.
It was bad. There was one guy,
Yeah,
just
but
like Gilbert Road
can I-
from Gilbert.
That's ridiculous. The storm outside literally threw a tree in the middle of the freeway,
That's scary.
and a car hit it and like flew up and flipped over on top of the tree.
That
It's
was wild.
That's how crazy it is outside right now. It's literally storming and like blowing wind like crazy. When we get rain, it's hardcore.
Where are you in Arizona?
Mesa. It's monsoon
Oh.
season, so in the month of August, we get most of the rain for the whole year basically.
Wow.
We get like, what is it, half the rain?
It was pretty bad driving in Colorado, too.
Yeah.
I don't know. This was the same where I was on that freeway. I was 130, 35. And
I would too. That's ridiculous. Can you guys hear everything that she was saying?
Yeah.
Oh my gosh, sorry.
There's this traffic on the road. It went up over the meeting in Toronto.
Yeah. Sorry guys. I didn't know you could hear everything she was saying. I just realized like no one was talking. Oh man. Alright, did you guys finish the last two? Do you guys understand it or do we want to?
Yeah, I got it. Did you get it, Alex?
Yeah.
Okay. You got 0.9599.
Yeah.
Yeah.
For 14, right?
Yeah, for 14. So 15, sample size is 36. What's the probability that the observed mean is between 37.5 and 42.5?
Which fried rice is that? Did you eat dinner?
So between, did you guys get, wait a minute.
For 15, I got 0.7887.
Okay, that is what I got. Oh, never mind. Yeah, that is right. I was looking at on the answer sheet, the top two are like 0.1056. That's if it's less than or greater than. So then the answer is 0.7887. Okay, yeah.
Yeah.
I feel comfortable with that.
Okay.
That's why I was like a little annoyed. I thought I got it wrong. Like, dude, how did I get it wrong? Okay. All right, so you guys want to just do the quiz?
Yep,
Are you ready, Alex?
Give me 1 second.
Okay.
Keep fat fingering on my calculator. I'm screwing it all up.
You're fine.
Okay. Let's do the quiz.
Okay.
Yeah, that's that now. Start quiz. So only has 15 questions. It's not too bad. The second one on Monday had like 18 or 21 or something.
Yeah, it was a long one. I'm ready whenever you guys are.
Yeah, I'm looking at question 3 right now.
I'm ready.
Okay, number 3 says use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places.
I got 0.175.
Yep, I got that too.
0.175.
Yeah.
Simple question.
It was very simple. Which of the following is a smaller standard deviation if 9 observations are randomly drawn from the population? Distribution of the individual observation. Distribution of the sample means. This cannot be determined from the information given.
If I'm right, it's the distribution of the sample means.
Why? I don't understand this question.
I'm trying to understand it still.
Well, I would assume that so the distribution of sample means is, it consists of a lot of observations. And so, I don't know, to me, it just makes sense that it will have a smaller standard deviation because when you gather a lot of observations, like they would.
Oh, yeah.
It just
Yeah. No, that makes sense because the standard deviation is how far the smallest from the greatest are, right? Right, so like the biggest number and smallest number, if there's a wider range, it'll be like a bigger standard deviation, right?
Yeah.
Yeah, like
So
No.
if you take the distribution of the sample means, the means should all be closer than if you get individual observations. So then the standard deviation shouldn't be as great if you took the means.
Oh.
It'll be more safe to bet on those numbers being closer, the means being closer than if you actually, because if you get one outlier in your number for an individual observation, it would make your standard deviation change a lot. But the means, if you took a mean from many samples, then they should all be a lot closer.
Close.
Those would be smaller.
That makes sense.
Does that make sense?
Okay. I agree now. Sorry.
So I don't know. Yeah. Sheila just knew it because she's smart.
I don't know, man.
She's
I
like,
just
Hilarious, Sheila.
like what you said, like the outlier thing, you know, like when you have the distribution of sample means, like the outliers don't really skew it because the mean already like kind of balance it out.
and even if you get multiple outliers in a sample, like if you have like a sample of 10, you get a number 1 and a number 10, and most of them are like a 4, 5, 6, 7, then the 1 and the 10 will just cancel out, and you know the mean would be like 5, right?
Yeah.
So whenever you take a mean like that, they should be closer together than if you just bet on, because you could, for the individual observations, it could have a smaller standard deviation if you got lucky, but it's a lot more reliable.
Okay. I'm on board.
So 5, which of the following results implies that the spread of x decreases as the sample size increases? Be the central limit theorem. And that basically is kind of the same reasoning that we just said.
Right.
The more numbers you have, the more they kind of cancel each other out and have a pretty stable mean. So yeah, central limit theorem. Does everybody agree with that?
Wait, so why isn't it the law of large numbers?
Yeah, I think it's law of large numbers. In my notes, I just wrote as sample size increases, standard deviation will get smaller. And that's just rephrasing this question here.
Yeah.
I think the central limit theorem is more about the curve becoming more normal, and the law of large numbers is about the number
Okay.
and the values.
I'll second that.
Yeah, I can agree with that. So law of large numbers.
Okay.
We know it's one of those two for sure. So if we get it wrong, we'll just go to central limit theorem.
Yeah, sounds good.
Last time we were like, we said law of large numbers and then it was central limit theorem. I just picked that one because I don't know. Last time I thought it was law of large numbers.
I get them mixed up.
Yeah. So it's 6. Here, and I'll be back in like half a second. I gotta grab my charger.
Okay.
Oh, and when this quiz is done, I think we need to talk about our group project real quick.
Yeah, I was just thinking about that.
Okay.
Do we have to record talking about our group project? And like post it or anything, or no?
I think one person has to post something this weekend.
Then
Like a video, or is it an assignment that we have to submit?
An assignment to submit. There's like a there.
So since I had issues with the recording last time, I'm gonna stop the broadcast after we're done talking. And I think we'll still be able to talk. It just won't be live anymore. And we can, is that okay? We can just talk about it offline instead?
Yeah. That's
Yeah.
good.
All right. So for question 6, we need to calculate a z-score.
Did you guys get negative 1.05?
I got 1.05. Oh, did I switch them? No.
Maybe it's me who switched them.
Is it the value minus the mean, or is it the mean minus the value? I can't remember.
it's the value minus
I'm
the
second
mean.
guessing. Oh, okay. All right.
It's the value minus the mean, so you should be getting negative 9.2 on the top.
I got negative.
Just on the top before you do anything
Yeah,
else.
1.045 positive.
Yeah, I got positive too, because if it's the value, or if it's the value, then that's the score of 160, and then you'd subtract the mean 150.8, and then you divide that by the standard deviation.
8.8.
Yeah.
It's the value minus the mean, so it should be positive.
Okay.
And z-score round to
Oh, okay, yeah.
0.045.
I said it, and then I just switched the numbers.
Oh, 3 decimals. 0.
Yeah, so 1.045.
So then we'd put for question 7, we're looking for a probability. So we just put the z-score into the applet, right?
Mm-hmm.
And would score, what's the
So
question?
1.0.
Score above 160.
0.148.
Yeah, that's what I got.
Yeah, I got that too. Did you guys put 1.045 on question 6, right?
Yeah.
Yeah.
Yeah, it's 1.05 because only round to 3. Wait, never mind.
3 decimal places. Okay.
Yeah. I'm sorry. I thought it said 3 decimal. I thought
Or-
there was like numbers in general, but
3 sig figs.
I did that too at first. It's
That's why I was clarifying it, because I was unsure. Okay, so question 8. Sample of 5 students have selected take GRE. These are their scores. What is the z-score? To the sample mean. Okay.
The mean
Add them all up and
is
divide by
100.
5.
In which case, I think it's the exact same. It's 1.045. Right?
question 8.
Yeah.
Yeah, so the mean is 160.
160, which is the same number we were working with in question 6.
What is the
Yeah.
z-score?
Calculation is the same.
I think you're right.
And that means question 9 is the same as question 7?
1.0.
Well, I don't think so. I think we need to use the other formula for that
Oh, okay.
because the sample size. Oh, so did we do the other one?
Samples keep changing. So then this is where it's 160 minus 150.
So I think that maybe we did question 8 wrong too because the sample size is 5.
Mm-hmm.
Oh, so we got to do the
So we
z-score
have to-
differently. We got to use the other equation.
Yeah.
Let's divide by the square root of 5. So 160. I hate all these tabs with the function.
For my new z-score, I got 2.337, which I guess would round up, right? 2.338, 2.3377707.
You got 2.338, you said?
Yeah.
That's what I got too.
Okay. Is that right? We would use the other formula, right?
Yes, yeah, because they gave us a sample size this time.
Okay.
Good catch.
So which other formula did you guys use, just to confirm?
The weird one with the square root, like the standard deviation divided by the square root of the sample size.
So it'll be 8.8 divided by square root of 5?
Of 5. Mm-hmm.
Wait, why are we doing that one if that one calculates standard deviation for possible samples? Aren't we still looking for z-scores?
Well, no, it's the z-score. Oh no, am I wrong?
Well, let's see. Trevor's flipping through tabs. I'm flipping through pages. I think over the one-on-one.
Yeah, this is frustrating.
Looking at
Should have
one,
looked at my mouse.
Just
the 160 minus 150.8. So divide that by
8.8 divided by the square root of 5.
8.8 divided by square root of 5. For 0.594? No, nope. Scientific calculator, screw me up. Hang on. I'm going to get this sooner or later.
yeah, it's a z-score formula.
Okay. 0.8 divided by square root of 5. 0.9.
Question 9. Asking for 4 decimal places.
But question 9's easy, isn't it?
2.338.
Yeah.
Yeah. And then for 9, I got 0.0097.
And all we do is plug that z-score from question 8 into the applet, right?
Yeah, that's what I did. And then make sure that only the right is highlighted because it has to be higher than that.
Yeah.
All right, so are we all on 10 right now?
Yes.
Yeah.
Okay, so suppose the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known this is left skewed. Random sample is n equals 81. So a random
Wait,
sample of 81 students will be drawn.
Question 9 real quick. Was it 0.0097?
Yeah.
9.
Sorry.
Okay, so that is a fairly large sample size. So because of that, are we saying it would be approximately normal?
I think so.
Or would it be wait, it says it is well known that this distribution is left skewed. So out of all the BYUI students on campus, most of them get a high GPA. Okay. I don't know, I say it's probably approximately normal because it has a high population size.
That's what I think.
But maybe, I don't know. All right. Then 11, what is the mean of the distribution of the sample means? All possible samples of size 81 that can be drawn from the parent population. Okay. The mean for all possible samples of size 81. Would it just be close to the original? Would it be close to 3.5 because it's a big population size? Or do we have to calculate it?
I don't know. I think it's 3.5, but I really have no reason why. I don't know what the real answer is.
Well, I think that because the original mean is 3.5, and we have a large sample size, it should be around that because we have a large enough sample size that it should stick to the normal, which would be 3.5. We don't really have any other numbers to go off. We have a sample size.
That's
And then
literally
the
like
original mean and original standard deviation, but they didn't give us anything new.
I think it
Yeah.
also says to round to 1 decimal place, so I'm thinking that you're right.
So 3.5.
Yeah.
Okay. And then 12, what is the standard deviation of the distribution of sample means?
We're saying 3.5 for question 11.
Yeah.
So would the standard deviation just stay the same then too? So 0.7. This one says round your answer to, oh wait a minute. Round your answer to 3 decimal places. Okay. That's gonna be a formula. So if we have a sample number, that's n, we have a mean, do we have a value? What is these for even?
Wait.
Wait, the standard deviation of a random variable
right.
x is standard, or is the weird symbol over the square root of n?
For 12, I have 0.078.
how'd you
How
get
did you
that?
get that? Oh,
0.7 divided by square root of 81.
Yeah, it's the if you look at the so the equation is for standard deviation of a random variable is that weird symbol, is that omega over square root n. So it's standard deviation over square root n. So we take the 0.7 and divide it by square root of 81, which is just 9. So 0.7 divided by 9. Is that what you did, Alex?
Yeah, I just did 0.7 divided by square root of 81. And then rounded to 3.
point
Divided by
That one is
078.
0.078. That's what you said, right, Alex?
Yeah.
Okay. Awesome. Does everybody agree on 0.078?
Yeah.
So 13 was the probability of the mean GPA of 81 randomly selected BYUI students would be less than 3.3. So let's do that other equation, 3.3 minus 3.5, or no, 3.5 minus 3.3. Whatever, doesn't matter.
I got 0.0051. 0.005.
Yeah, minus 3. -2. Be less than, so we'll just click the left. You got 0.0052, is that what you said?
0.0051.
That's close enough. I might have just rounded differently. What do we got to round to? Is it just the third decimal place?
The third decimal, yeah.
Okay, so just 0.005.
Yeah.
Okay, so it's 3.3 minus 3.5 divided by 0.7 over square root of 81, right?
Yep.
I'm getting negative 2.571.
Yeah, that's the z-score. And then you plug it into the
Plug
applet.
that into the applet.
Right.
Oh, did you guys do 0.07 repeated?
I passed this class because you guys are dragging me with you.
Yeah, I pretty much got that, but I just kind of left it in the equation instead of putting the one that's repeated. You know what I'm saying? Instead of putting, I did 0.7 over 9. Yeah.
I just did 0.078 and threw that in there instead of calculating it. That's why I think I got my number was slightly different because I just rounded instead of doing the exact z-score or exact standard deviation.
0051.
Yeah.
So, yeah, and then we just rounded to 0.005. And then for 14, that one was easy. It's just all the rest of it. So it'd be 0.995. So you just take 1 and subtract the 0.005. Or you can go back to the applet and unclick the left side and click the middle and right, and you get 0.995.
Right.
So that one was easy. And then 15, I haven't started reading it. It looks scary.
It's usually a ton of fluff.
Yeah, I'm sure we're just going to calculate that. Yeah. All right, so we ready for 15?
Yes, yeah.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. Dang. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. So we just got to use that equation again, the 185 or 177.6 minus 185, and then the standard deviation.
Mm-hmm.
The standard deviation was 26.7, and the sample size was 48 because there's 48 passengers on that boat of a random sample of 48. So we're taking 48, so that should be n, right?
Yes.
Okay, so let's just find the z-score.
I got negative 1.9201.
Me too.
I'm too stubborn to actually grab my calculator, so I have to
Then we go
calculate the bottom number and then just remember it.
applet.
You guys got a z-score of 1.92.
Yep.
Yeah.
And they said above or below, so we just click the left and the right side.
Right.
0.5 or 9.
Yep.
And then look at the third decimal. Yep. So 0.055.
Yep.
Awesome.
I'll submit. Looks like we got them all.
Yay!
Oh, no, wait, question 3.
Okay, backing out.
Oh man, how do you back?
What'd you put for 3?
For 3, I put 0.826.
I put 0.175.
0.175. I'm not even sure where 0.826 came from.
And that was the only one?
That was the only one.
Here, I haven't submitted yet, so I'll just stay if you want to go back to the quiz. That way you don't have to.
It's an A. That's good enough for me.
Are you sure?
Yeah. I'm just trying to get a B here, so.
Yeah, but every little bit helps to buffer because the exam's like, what, 60%? Hey, do we have an exam this week?
Next week.
Next week? Okay. I knew it was really soon. So it was like one of the first weeks. That means we basically have one every week after this week.
Great.
Awesome. Okay, so we're done with that. So all we have left is to talk about the final project.
Yes. Let me stop our broadcast for a minute.